How do we change direction, change perceptions, and assist what we walk upon each day? Soil. My name is Chitnis, and I'm working on a project to save our soil through genetics, which will save us. For too long, we've been steering ourselves into a cycle of drought and starvation through our soil, and here's how. The presence of topsoil is necessary to grow about 95% of the world's food. But in the past 150 years, human farming practices are exhausting the topsoil, and soil degradation rates are rising faster than ever before. If we continue at this rate, and if we don't change our direction, all of the world's topsoil could be gone in less than 60 years. Without topsoil, we can't grow food, we can't supply nutrients to plants, we can't filter water, and we can't sequester carbon. But it's more than just food systems. Hydroponics is a method to grow crops without using soil, and it's been growing in its popularity because people see it as a solution to future food shortages. But the topsoil and the soil is alive. So if we submit to this method, we're giving up on the soil's power to save itself and us. Think about things like this. You are what you eat. If we begin to eat food that's grown without topsoil, that changes us. In fact, that change is revolutionary because saving our topsoil isn't just a matter of the food. Topsoil grows food. Hydroponics grows food. But topsoil helps prevent famine. Topsoil can help prevent drought. Topsoil is necessary for the animals to live and for the earth to live. So topsoil isn't just about agriculture. It's about the butterflies, the birds, and the deer. When conventional farming methods kill the topsoil, we're killing entire habitats and ecosystems. So yes, hydroponics can help to grow food. But if we lose our topsoil, the ecosystem of the earth will never return. Without topsoil, desertification spreads all over the world, creating desert-like conditions. And the main reason why this happens is carbon. Soil is the world's biggest carbon sink, which is why it's so necessary for topsoil to sequester carbon into the ground through a process known as carbon sequestration. But if we lose our topsoil, we can no longer absorb carbon into the ground. And then where do you think the rest of the carbon goes? That's right, the atmosphere. More carbon in the atmosphere correlates to an increase in global temperatures and an increase in our inability to prevent drought. This week, the National Oceanic and Atmospheric Director predicted that with the rising temperatures in the very near future, our chances for megadrought will worsen, especially in the western United States. Now, there are management practices to improve soil health, including cover crops, no-tillage farming, reducing pesticide use, and increasing soil organic matter. These are important practices, and they do help, but they themselves won't stop the catastrophe from happening. If we can't bring topsoil back to its natural state, then we can't live on planet Earth, and neither can the rest of the species that we share this planet with, the flora and the fauna. Life will stop when the topsoil is gone, and we'll create a desert-like condition, perhaps similar to what Mars is now. So, loving nature and understanding this vital connection between soil and everything else on planet Earth, I found a way to prevent everything I just described from happening. I sat in my bedroom many days last year, researching soil structure and genetics, because I was drawn to an idea in my head that maybe genetic engineering could solve global soil degradation. At that point, I knew that I cared deeply for the soil, so I put the two together, genetics and soil. I began contacting professors and pitching my ideas, which went on for months and months until I met Dr. Rian van Hinukten, the inventor of the Hydros program. He agreed to talk to me over the phone and Skype, and he taught me the physics behind soil processes using his program. He also believed in my ideas with CRISPR to genetically modify a microbe so that it attaches it to soil and attracts water. Together, we conceptualized and created the first form of this project. When we first started, this project simply served to genetically modify a microbe attach it to soil particles that attract water to the soil particles and then increase soil water content. I thought this was a really good idea, but I didn't know which microbe I wanted to edit. So I went on contacting and researching, trying to find that microbe, until I realized a more efficient solution. By increasing cellulose production in the soil, by editing the genes of bacteria that have already been edited in the past, we can increase water content without the fear of introducing a deadly pathogen into the soil. So to do so, I found a bacteria that's already been engineered, and that is Acetobacter bacteria. I plan on performing an experiment in which I'll edit the bacteria using CRISPR genetic engineering technology, and I'll overexpress the gene that produces cellulose in Acetobacter. If we increase the cellulose, we increase the water content, and then we have the chance to reverse the drying of soils. So by genetically modifying the soil, we can reverse global soil degradation and stop the chances of the rise in temperatures, our chances for drought, and our chances for mass starvation. So not long after Dr. Van Henoten and I created the first forms of the project, I met a permaculturist who agreed to speak with me about my project. Now, she was completely against bringing any genetic engineering and technology to her soil. And the things she said and her angry words hurt me and made me question myself. And I almost lost sight of what my heart told me. But only almost. I held my ground and I contacted Dr. Ratan Lal, winner of the World Food Prize 2020. He is very devoted to our soil and has created award-winning solutions to increase food security through soil carbon systems. In the past year, he and I collaborated to establish realistic boundaries with soil for my project and to talk about how we could increase soil organic matter through my project. After talking to Dr. Lal, I knew that it was important to expand my network even more, even outside of the United States. So I contacted Natalie Coles from the British Society of Soil Science, and they offered me a spot as an associate member. This membership led me to a wide network of professionals, and that led me to contact of Dr. Mary Beth Kirkham from Kansas State, and she began to be my experiment mentor. She had really good ideas for an experiment, and she gave me a lot of hope. But with COVID, I knew it would be difficult to perform an experiment in a lab. So I've built a greenhouse in my backyard in which I'll genetically modify Acetobacter bacteria with the help of a lab using CRISPR, insert it into synthetic soil by means of a water spray, and then check the water content using a model SC1 leak parameter. So I pitched these ideas to Dr. Shungan Park and his colleagues at his lab in Kansas State University, and they offered so kindly to help me using CRISPR with soil and to find the ways in which this project and experiment will actually happen. Together, I believe that we can show the world that CRISPR and genetic engineering will save the soil. A few months ago, I met Dr. Catherine Reardon from the USDA, and she is a soil microbiologist. She and I worked to find the microbe that we will edit, which we now decided to be Acetobacter bacteria, and our goal was to find a microbe that has been engineered in the past, so permissions wouldn't be a cause of concern. Dr. Reardon introduced me to Dr. Kristen Tripp, and Dr. Kristen Tripp is also a soil microbiologist from the USDA, but she has also explored CRISPR with soil, and I plan on using her advice and her expertise to help me with what I want to do. The scientists I work with have opened their hearts to me, so I can stand on their shoulders, and together we can come up with something new. Because that's how science works. By standing on the shoulders of these scientists, of Dr. Van Henoten, Dr. Lal, Dr. Kirkham, Dr. Park, Dr. Reardon, and Dr. Tripp, we have a chance to create something unique. Science is a collaboration. Science is connected with nature, and that too is evolving. With my research, I have to demonstrate the importance of bringing genetic engineering and nature together, as engineering and nature have long been connected and will continue to be connected, especially because engineering has evolved through nature. All of engineering is born and based on biomimicry. Many of our engineering designs, like the Tokyo bullet train, for example, are based in natural design. In the case of the bullet train, engineers wanted to conceal the very loud noise that it made. So they were inspired by the hummingbird, called the kingfisher, and they made a new design in which they mimicked the hummingbird's nose and beak, in which it would move very fast, but very quietly. When the topsoil is gone, and we lose the ability to sustain life on Earth, there won't be another hummingbird to make a bullet train, because we won't have biomimicry. So that's why these scientists and I are working together to evolve our perception of the soil and Earth. Like engineering and biomimicry, my project evolves day by day as I meet with these professors and scientists. They show me how important it is to advance our perceptions of soil, engineering, and nature. And by trying something new, because what we've been doing for hundreds of years hasn't been enough, I too am evolving. And that is what evolution is to me.